So good morning, everyone. So today I am going to discuss a new topic that is glycosides. So in this topic, you will going to learn the definition, their classification, and we will discuss about the properties of this glycoside also. So first of all, let us see the definition of glycosides. So these glycosides are organic compounds that can be obtained from plants or animals and which on enzymatic or acid hydrolysis. It undergoes into two parts. One is sugar moiety, another is non-sugar moiety. So sugar moiety is called glycom, and non-sugar part is called aglycom. So here you can see that this is the glycoside. When it undergo hydrolysis by acid or enzymes, it will give you glycom and aglycom part. So this glycon part is sugar moiety and this is non-sugar moiety. So this sugar moiety is actually responsible for the solubility of glycoside, and non-sugar part is responsible for the therapeutic activity of the glycosides. So chemically these glycosides are the acetate or sugar ether. This is formed by interaction of hydroxyl group each of non-sugar and sugar moiety with loss of water molecule. So when the sugar molecule and non-sugar molecule will combine together, then what will happen? Uh, they will lose one molecule of water when they interact with each other, and they through this glycosidic linkage they will form the glycosides. So this hydroxyl group of a glycol may be of alcoholic, phenolic, or in some case it may be amines. But sugar which are present in these glycosides most commonly is beta-D-glucose, and other sugars are also present in the glycosides. These other sugars just like lactose, mannose, rannose, distoxose, and saccharose are also present. So these glycosides are present in plant in different parts, as like leaf, bark, wood, flower, and seeds, and in other parts also. So these glycosides play a vital role in healthcare systems, and they show different therapeutic activity. So now let us see the property of glycosides. So these glycosides are actually uh, colorless crystalline and bitter tasting compounds. So they are generally soluble in water and alcohol, but these are insoluble in non-polar solvents just like ether, chloroform, and benzene. So in dry state, they are stable, but when in presence of moisture, heat or acid or alkalis or enzymes, they undergo hydrolysis. So when this glycoside undergo hydrolysis, as I discussed in the definition, it will break down into two parts. One is glycon and another is aglycon parts. So the linkage between the glycon and aglycon may be O, maybe C, maybe N, or maybe S, sulfur. So it may be oxygen, carbon, nitrogen, or sulfur, the glycosidic bonds. So now let us see the classification of glycosides. So glycoside can be classified in two different ways. So one is on the basis of the chemical nature of a glycon parts, their therapeutic activity, and another is on the basis of their glycosidic linkage between the glycon and aglycon parts. So first of all, we'll see the classification of glycoside on the basis of the chemical nature of glycon moieties. So it can be classified into following types, just like anthraquinone glycosides, example isolosides, RAIN, barbaloin, steroidal or party glycosides, just like purpurea glycoside A and B, then sclerin A and B, then saponin glycoside, just like diisogenin, sataborin 1, 2, and 3. Then cyanogenic or cyanophoric glycosides, just like amygdalin, pronacin. Then 5 is isothiocyanate glycoside, just like sinigrin. Then 6 is flavonoid glycoside, just like vin, zincolid, A, B, C, and rutin. Then coumarin and furanocoumarin glycosides, just like coumarin, kaolin, and bisnaggin. Aldehyde glycosides, just like glucophenylene and isophenylene. And phenol glycosides, just like arbutin. And then is pterodyl glycoalkaloids, just like solasodine. And glycosidyl bitter or miscellaneous glycosides, just like andrographylate, lotion, and picrosides. So, on the basis of the chemical nature of this chemical nature of the aglycone part of this glycosides, it is divided into 11 types. Now let us see on the basis of the glycosidic linkage. So it can be divided into 4 types, just like C glycoside, O glycoside, N glycoside, and S glycosides. So let us see first the C glycosides. So in this type, the sugar is linked to the glycone by carbon atoms. So this C glycosidic bonds. So now you can see here, this is glycone and this is a glycone. When they will lose one molecule of water, then it will form this glycosides, and this is the carbon is the glycosidic linkage. So example is this type of glycoside is found mainly in anthraquinone type of glycosides, just like aloin, ascaroside, etc. So these all type of glycosides. So here this glycone and glycone they link through this oxygen. Okay, so here you can see this is glycone, this is a glycone. So they will lose one molecule of water. This will form glycone and glycone. So this O glycosidic linkage. So example is Senna and Ruba. And this N type of glycosides. So this type of glycoside is mainly found in nucleosides, where the amino group of base react with OH group of ribose or deoxyribose, and ultimately they will give you an glycosidic form. So here you can see this glycone and a glycone, then they will lose one molecule of water, then this will form this glycosidic linkage. So this is N type of glycosides, and this is S type of glycosides. So this S type of glycoside is especially found in the isothiocyanate type of glycoside, just like sinigrin, which is present in the masters. So they are formed by interaction of sulfhydryl group of a glycone and hydroxyl group of glycone. So this is when this glycone and a glycone they will combine, they will lose one molecule of water, and they will form this S-glycosidic linkage. They will form the glycoside through S-glycosidic linkage with the loss of one molecule of water. So thank you. Please subscribe my channel so that it will give me energy to uh, prepare some more slides for new topics. Okay, thank you.